Okay, so it is finals week, and in geometry we do have 3 options for our final exam. Your first option is going to be your traditional written final. Hello, we're about to talk about finals. If you choose to take the final like normal, you will complete a practice final that we will go through together today. And then you'll just be able to use this, any notes you have, and you will take the final. Easy peasy. We're all kind of used to that by now. But here's the other 2 options. So the second option is that you can create a poster. And here is the rubric for that. And Mac, the rubrics are up at the front and the practice final, so you're welcome to take one of each or just one, whatever you think you might want to do. So for your poster, you will be able to read through these categories. These are what I am looking for when I grade your poster as your final. You will choose a unit that we went over, or you could choose a unit that we haven't gone over, just something geometry related. Just ask me if it's okay that you do it if you choose something we haven't done as a class, just to make sure it will fit with the poster theme. Anyway, you will need to have the title written at the top of the poster and a brief description of what that topic is. You will be able to read through for each category how many points you will get for a certain quality of work. The next category is vocabulary and symbols. You'll need at least 5 terms that are listed and defined. Now, those could be anything as simple as, in geometry we have lots of vocab words. Square, rectangle, line segment, angle, lots of words you can define. You should have no problem finding 5. And you can obviously go down the line and see how many points will you get if you do less than 5, or if you don't make your definitions accurate the way they should be. The next thing on your poster will be example problems. You should have 3 or more fully worked out examples that show each step clearly, correctly, something that would be a guide or an aid to help someone who is learning this material. Next is visuals and diagrams. So you should have at least 2 visuals on your poster. I think geometry is very visual. You should not have an issue including pictures. And finally, I'm just grading you on neatness and general organization. I can tell pretty easily how much time you've spent on your item. If it's obvious that you slopped it together in 5 minutes, your grade will reflect that. If you organize it, make it easy to read, it's visually appearing, I can see everything, it looks good, you'll get your 10 out of 10. So this is worth a total of 60 points. You can earn bonus points for exceptional effort, creativity, or additional content that is more than I'm asking for. So that is the poster option. Before we talk about the other option, do we have any questions about the poster? Okay, so I'm going to move on now to the 3D shape option. This one I'm excited about, just because I feel like I would have liked to do this when I was a student. So basically for this option, you will research and choose some sort of 3D shape. Now, we have not talked about 3-dimensional shapes. Just a quick overview of what that is. For example, a rectangle, that is a 2-dimensional shape. It has a height, it has a width, a length and a height, whatever you want to call it. A 2-dimensional shape becomes 3-dimensional when we add that third dimension, suddenly now we have a box, a rectangular prism. Thank you. So now we have a box. Basically, a three-dimensional shape is a shape that is made up of a bunch of two-dimensional shapes. All this is 6 rectangles glued together. There's one in the front, side, back side. There's the 4, 5, 6. Just 6 of them put all together. Kind of cool. And you can make a lot of different 3D shapes out of 2D shapes. So here is what I will be grading you on. First of all, the accuracy of your three-dimensional shape. To get 10 points, your shape needs to be constructed correctly with precise folding and edges are aligned perfectly. I want it to look really good, okay? If your shape is mostly correct, but it's got some minor misalignment or errors in folding, 8 points is still fine. That's a B, you know, it's good. But I want you to be a perfectionist when you do this, guys, because this is mathematical. I'm letting you do an art project instead of a test, so we want to be good at it. We want to be precise, okay? And then you can read down the line and see what happens to your points as your accuracy becomes less and less. Your points will do the same. So here are some of the new terms that you will need to practice if you want to do this option. You will need to calculate the surface area and the volume of your shape. What is that? We'll talk about it. So we're going to get into more details about this later, but just to go over this, basically to get all 10 points, your calculations need to be correct. They need to be neatly presented, and your shape needs to be labeled in some way. How you label it, that is up to you, whether it be little sticks poking out of your shape with flags that explain what each part is, or if it's a separate guide that goes with your shape. However you decide to do that, you need to have your surface area and your volume written there somewhere and showing me your calculations and all of that. The next thing that you will need to label is all of the parts, such as the faces, and I will explain what all of these mean, the edges, and the vertices. So, 3 things that need to be labeled. Again, I will tell you what all these words mean once we've gone through the rubric. To get all 10 points, you label all of them. If you don't label all of them, your points will slowly drop the less you label. The next category is neatness and craftsmanship. Basically, I'm just looking to see that it is well constructed, clean cuts, folds, it's polished. Really similar to the accuracy category, but it's, you know, I don't know. They're slightly different, but they're kind of the same. Anywho, moving on, last category, creativity and effort. If you and your project demonstrate a high level of effort, creativity, and attention to detail, you'll get 10 points. If you show good effort, but you're not really being creative with it, and it's not like as nice and precise as it could be, you might not get all 10 points. And as that effort decreases, so do your points. And same with the poster. You can earn up to 2 bonus points on this project as well for going above and beyond. I'm not going to give you specific requirements to earn bonus points, but if you wow me, you'll get bonus points. Wow me. So that's how you do it. I don't know, I'm pretty easily wowed. So, anywho, that's the 3D shape project. So, do we
do one of these as well as take your test for both?
Yeah, absolutely. If you're not sure what you want to do, you could totally do more than one. Or if you, let's say you take the final and you're like,
Well, the only reason I'm asking
that didn't go so good.
I was working on this
Yes.
and I kind of made one already.
Ah, what did you make?
I made the triangle. I put
Ooh.
fairy lights in it so you can like hang it up.
Star, oh my gosh. Bring it in. I'll have to see it. You need
Well,
to show me.
I didn't know about the surface area stuff, so it's not technically finished yet.
Okay, okay. So you could add a little to it, make it
Will a
fit.
cylinder be?
A cylinder, yes.
Anything 3D. It doesn't
Anything
have to be
three-dimensional. Yep, absolutely. So,
decisive.
all of this being said, these are our options. Do we have any other questions about any of
I
these
don't have a
projects?
Question.
Uh-huh.
But actually, this is a question. Is there any example? Do you have an example for both of those? Well, I know example of a 3D shape, but like
I will give an example
like a
for each.
poster that you would.
So there's none that are readily made, but here's what I can do. I'm gonna show options for all three. First of all, today, if you are doing the practice final, I'm gonna upload to Google Classroom a video going through the practice final so that you can check your answers, all of that. And then if you are working on the other projects, I'm gonna kind of do a miniature version of these and show you what kind of work I would expect from you guys. Yes,
Is a cone a 3D?
yes, it is.
Okay.
Anything that is not a drawing.
Not flat.
Yes, it just can't be flat. Can't be flat.
Yeah, I'm gonna do the. I think I'm gonna do the 3D shape.
All right, so I'm gonna pause this real quick and, okay, so something you will notice on the practice final is there is lots of red, okay? That is because this is from term 2, from last term. The things that I have marked out, we did not get a chance to get to. So I'm not gonna be grading those. Those are free points for you guys. Wonderful. So on page 2, you'll see number 4 and 5. You don't have to do them. You can if you want, just for fun, but I'm not gonna grade them. On page 4 of the practice final, these are all, I made copies of the red marks. You will see it on yours. We did not talk about types of quadrilaterals. If you know the types, great, but I'm not going to grade it. And then on page 5, we did not really talk about circles. So, you don't have to do those. Now, on Thursday, we did talk about circles a little bit. But if you weren't here, that's okay. That's why these are not necessarily worth points. But what I am going to do with all these questions that I have X'd out is that if you get to the bonus question and you decide, I don't want to do this bonus question, you can choose any of the circled questions and do parts for bonus points. Now, it's not unlimited bonus points. You can earn up to 3 bonus points maximum on this final. And those will just come from all these different problems and whatever you decide to fill out. So, I'm going to post this video of me going through it from term 2. So on the video, you will, I will explain how to do the stuff we didn't go over. So you're welcome to listen to that. You're welcome to skip over it. But I will post that real quick on Classroom, and then we're going to look at the project stuff. So, uno momento. Okay, so I am first. Let's see. Is there anyone that's going to do a poster? Okay, no one in this room right now is thinking about poster. How many of you are thinking about doing the 3-dimensional shape? Okay, quite a few of us. So I'm going to give you kind of an example of the 3-dimensional shape. And we're going to talk about some of these items that are in it. Now, I'm going to give you a shape, and you're not allowed to do this shape. So nobody can do a cube. No one can do a cube, just me. A cube. So here's our example. First of all, something that is going to be helpful is if you do some research first, Google some things, and I would recommend looking up 3D shape nets. 3D shape nets. I would look this up on Google. And this is what a 3D shape net is. It's basically all of the parts that make up that three-dimensional shape laid out in one flat piece. So, for example, a cube is going to have 6 faces, and I'm going to draw them. So, a cube is basically a three-dimensional square, right? So here is a square. To make it three-dimensional, here's what we can do. I am going to draw more squares.
So you can write it down, but we can't.
Yes, you can write this down, absolutely, but you will just have to choose a shape that is not a cube. This is just like an example.
Ms. Taylor, I didn't know how to submit this online Friday.
What is it?
This is my ticket, my exit ticket, but I don't know how to submit it online from Friday.
You can always just send a picture to me.
Oh,
Yes, or you can always send me an email and just say, I finished my ticket, but I can't give it to you. So I finished it, and I will give it to you Monday, and I will say, that is fine.
okay, all right.
So for now, you can just put it in the turn-in bin, and I'll just remember that you did it last week.
Thank you so much.
Yes.
I'm sorry. Yeah,
That's all right.
now I know.
All right, so this is a net. Yes.
So, are we allowed to use like what type of paper are we?
That is a wonderful question. So you can use basically anything you want. You can use graph paper, you can use lined paper, you can use, I have colored paper that I will lay out for you all to use. Here, I'll put some up here. So there's like construction paper in here. I will get some scissors for you guys. Let's see. Oh, and I have something that's going to be super helpful. I don't know why I'm drawing a picture when I could just show you these amazing, wonderful things. So, let me show you my cube. This is a cube, okay? My three-dimensional shape. And the net of a three-dimensional shape is the drawing of the two-dimensional pieces that come together to create the shape. So here's what's cool about these little figures I have. This is three-dimensional, but what comes out of it is the pieces that make it up. So, look at that. This is my net. This shape will create a cube for us because we have a square here, and then what happens is we have 1, 2, 3, 4 more squares coming off of the sides. We fold those up and they become the outer edges, right? And then we have one last square that is the top of our three-dimensional figure. What you would do once you cut out your shape like this, you would research a net of whatever shape you decide to do. You would cut out that net and you can tape it together or use glue to put it together or whatever you decide to use to put your shape together. And you're going to create a three-dimensional shape just like that. So you will find a net that's going to help you to create your shape. And let's see, let's talk about all the things that we need to look at. Okay, so I'm going to look at the next category where it says surface area and volume. And let's talk about what those mean. And we'll talk about surface area first. Now, before you choose your three-dimensional shape, I will say we have not done as much practice with curved shapes. So if you do pick something that has a circle in it, it might require a little bit more researching to figure out how exactly to do that. But if at any point you need help, just talk to me and I'm happy to help you with it. But here's what surface area is. Basically, let me ask you this first. What is area? You guys know what area is? We just learned about it.
The inside of the shape?
Yeah, it's like the inside of a two-dimensional shape. So I could find the area of one of these squares.
And it'll all be the same as the rest of them, right?
Yes. So let's see. Now, only if you have a regular 3D shape. Yes. So like a cube has every single...
Size the same.
Yes, all the sides are the same. Now, if you have something like a rectangular prism, which that would be like this, then all of your faces, the flat parts, are not the same. Some of them are bigger, some of them are smaller. So you would have different calculations to make. So surface area is the area of each of the sides added together. So, for example, in my cube that I'm drawing, the length of each side is 3 units. Okay, so if I have 3 units by 3 units, what would be the area of this one square? 9. Good, because we're just doing 3 times 3. So this would be 9 units squared. So to find surface area, what I'm doing is I'm finding the area of each face on the shape. So in this shape, I have 1, 2, 3, 4, 5, 6 faces that are all the same size. So surface area is area of each face added together. So if I have 9 units squared as my area for one face, and there are 6 of them that are the same, I'm just going to take this number, and I could either do 9 plus 9 plus 9 plus 9. I could do that 6 times, or I could do times 6. Because there are 6 faces here.
So 54 squared?
54 squared, yes. So my surface area of my cube here is 54 units squared. This would be my surface area. Yeah. And I can define this as well. A face on a 3D shape is just, it's basically like the side of it. So any of the flat portions, this is a face, this is a face, this is a face.
Vertices?
Vertices?
Vertices is the corners, right?
Yes, the vertices are the corners.
Sides.
Mm-hmm.
But on a cube, is there a side? What?
So let's see, we have faces, edges, and vertices. So let me actually use some colors and label this. Okay, so this is a face. This, basically the fold in between each face, that is considered the edge. And the vertices are the corners. So like any of the points on the shape, that's a vertice, that's a vertice, that's a vertice. It's like so once you've made your 3D shape, my question to you will be, how many vertices are there? How many faces? How many edges? So I'm going to draw a 3D version of this, and I'm going to show you how we could kind of label that. So let me just redraw my square and turn it to a cube. Okay, there's my cube. And if you have graph paper, these are really easy to draw. I can totally show you guys. So on my cube, for example, how many faces does a cube have? 6. And here's a good way to check that. If you guys want to see any of these shapes up here, by the way, you're welcome to. You can open them up, look at the nets, see if they look difficult to make. I will have these up here. You can peek at them. So I could just count them like this. Okay, here's one side, or one face, 2 faces, 3 faces, 4 faces. Oh, I already counted that one. 5 faces and 6 faces. There are 6 faces. Now they're all covered by X's.
So you want us to draw on our, or before we put it together, maybe write on it?
You can choose how you want to do it. If you want your shape to be labeled, great. If you want to have like a key to the side like this, you can do it that way. If you want to have little toothpicks sticking out of it with flags that label it, it's really up to you how creative you want to be with it. As long as all of the information I'm asking for is there in some way, shape, or form, I will be perfectly happy with that. So I would say a cube has 6 faces. And then we could count how many vertices. So that's how many pointy parts does it have? Let's see. 1, 2, 3, 4, yep, 5, 6, 7, 8. It's got 8 of them. 8 vertices, 6 faces, and then I need to count the edges. So I'm going to use blue highlighter and show it on here. I could count my edges like this. I have 1, 2, 3, 4, 5, 6, 7, 8. Is that all of them?
No.
Ah.
9, 10, 11, 12.
9, 10, 11, 12. Good. So 12 edges. 12 edges. And then I've got my 8 vertices. 1, 2, 3, 4, 5, 6, 7, 8. And here's just an example of a way you could label it. You could color code your shape. You could draw a picture to go with your figure. It's up to you how you decide to portray everything. And there's my faces. Okay, so that would be listing off my faces, edges, and vertices. Let's see, we didn't talk about volume. You want to talk about volume? Let's talk about volume. So there's surface area. That's just the area of all of the faces added together. Now volume, I will give you a formula. Volume is going to be length times width times height. So for a cube, my length would be 3, my width would also be 3, and my height would be 3. If I were to be doing a shape like a rectangular prism, I might have different measurements. Maybe my length is 10 and my width is 7 and my height is 3. It just depends on the shape you make and all of that good stuff. Now this will also be different if you choose to do a circular shape or a shape that is not squarey. So this formula, I want you to make sure that if you are finding the volume of a shape that is not squarey or rectangular, look up all the formulas, make sure that you're doing them correctly. If you decide to do a pyramid, for example, search volume of pyramid formula. Make sure we're looking at the right things for the shape you choose.
So if I do a cylinder
A
or
cylinder.
a cone, I won't have vertices or edges.
You will have slightly different name. Let me see what we would call it. I actually have a sheet with all these formulas. You said a cone or a cylinder?
A cylinder or a cone.
Okay. So either one, here's an example, and I will happily let y'all look at these little cheat pages as well. Here. So for a cone, you would have the surface area would be finding the base surface area and the side surface area. Now that's going to be a little bit funky to find the area of a weird shape like this. Your cone is going to be a little tricky.
Okay, cross that out.
So no cone, unless you just want to. Cylinder will be a little easier because it's just 2 circles and a rectangle. So to find your surface area, you would find the area of the 2 circles and the rectangle in between them. To find your volume, you would do base area, yes, times height. Now your base area would be one of these circles area, and the height would be the distance between these 2 circles. So let me see if I can, like here's a cylinder right here.
Isn't that height?
Yes, it would be like, this is the base area. The height is this measurement from here to here. So whatever this is times that length or that height.
Do you happen to have a triangular prism on there?
Yes. Triangular prism. Well, triangular pyramid. Triangular prism is different.
Okay.
Oh, we do have a triangular prism. Okay, right here. So, triangular prism looks like this. Your surface area of the whole shape is going to be whatever the area of your two base surfaces, your two triangles, and then your three side surfaces, your three rectangles.
What does that word say on the side? Because I cannot see it. It says. Thank you.
No problem. Where? Surface area, three side surface areas plus two base surface areas. And then your volume, same thing here. Your base is the shape, the triangle. Your height is the space from one triangle to the other.
Okay.
And again, you are so more than welcome to look at these and use them for inspiration. And use the internet, guys. It's a great tool. It'll give you so much help on this.
So you're expecting our our sheet to look like something like that?
So your finished product does not have to look like this. Honestly, I think what I'm gonna do tonight is I'm gonna do a project tonight so that you guys have an example to look at. Because I feel like it's always scary going and making a project whenever there's no previous examples. You guys are kind of my guinea pigs with this project. So I'm thinking tonight I probably just need to make one and show you what that might look like.
I don't want to do cube because it's basic.
Well, you could always do a rectangular prism. That's pretty similar to a cube.
Yeah, I was thinking of that or the triangular prism.
Yeah, any of them really. There's all sorts of good ones in there. But, so let's see. We've got our surface area, our volume, faces, vertices, edges. I mean, that's really all I'm looking for. Everything else is just making sure that your math is correct, making sure that it's nice and neat. And honestly, we have like 40 minutes right now left in here, so I think I'm going to keep this recording going, and I am going to work on making this cube project, and that way you guys can kind of watch the process.
Okay.
And who knows, maybe I'll have it done before.
You're expecting it to be huge? It doesn't.
It can be however big or small you want it to be. So I am going to do that. I'm going to get some fun paper too.
Like this pink.
I know, right? I love these Astro Brights. They're so bright. Orange. Okay. And this is the time to be a perfectionist. Oh my gosh. I have so many things on my desk. It's ridiculous. Now, and well, since you're just kind of watching me, I am going to put music on. Yeah. And I'm going to look for, here's these, you guys. I'm going to put these shapes where you guys can access them if you want to compare and look at any of them. I'm going to have them over here by the paper. And yes. I need to mark a 10. So. I will say using graph paper is super helpful for sketching out your shape and then maybe like tracing it onto your paper as a rough draft. It'll kind of help give you accurate angles. Or you could use a protractor, obviously. And your measurements can be whatever you decide them to be. It can be inches, centimeters. You can make up your own unit if you want. Let's see. For a cube.
No idea what you mean by accurate and not slanted or anything like that.
Yeah, it's got to be super accurate or it won't fit together, those pieces. But yeah, I'm just gonna keep working on this and maybe it'll give you guys some ideas. So right now I'm just drawing my net. Okay. And you guys will have all week to work on these. So if you get excited, you can work on them at home, obviously, but you will have class time to do it. And lots of it. Uh-oh. I missed a measurement. Did I do this one right? Yes. I messed up a whole bunch on this. Oh my goodness. Okay. Well, I actually did need this one. So here's what I'm gonna do for my labeling. For example, and you don't have to do it this way, but like for my vertices, I'm just gonna color them all the same color. So there's that.
I know this is past the fire. I guess I could go to Dr. Room. But isn't it like I borrowed the room, one room and bring it back to me?
Yes, yes, that's fine, absolutely.
Thank you.
No, I don't mind that at all. Yeah, if you guys need to borrow any materials and take anything home, like compass, ruler, protractor, things like that, just let me know and I can write your name on a sticky note and what you're borrowing. And as long as you bring it back by the end of the week, that is fine with me.
You would need a protractor for the three-dimensional?
Only if you are wanting to like measure angles and things like that. It just depends on how you're constructing it. Like I'm not using a protractor because I'm using grid paper. So it's already got all my 90-degree angles there.
Oh.
But if you're doing like a freehand shape, it might be helpful to make sure your angles are correct. It really just depends on the shape you choose.
I'm doing a triangle for
Okay, so it depends on what kind of triangle you want to make. Like if you wanted to make,
I'm going to make the one without sides the same.
okay, so that would be an equilateral triangle. So you would need to make sure that every angle in your triangle is 60 degrees
Okay.
because that is what angles an equilateral triangle would have. So like for example, if I decided I'm going to make an equilateral triangle and I want my side length to be 3 inches, I could start with 3 inches here and I know my first angle is 60 degrees, So I'd line it up, mark it at 60, and then see like 3 inches from there. So here's almost right at it. There's 3.
And then you just connect the other two.
Yes, and then the other one should be right at
So I would need
3.
a protractor. I would need a protractor.
You might need one just to double check your angles. Yes. And you're welcome to borrow one. Just let me know if
I'm about
you.
to do it now because it's true.
But you're going to take a ruler home.
Yes, no, I want to
Okay.
a ruler
Yeah,
and a-
absolutely.
Just both of these.
Ruler and protractor. Perfect. I'm just going to write that down. Okay. No problems. Yes, see you tomorrow.
3 more days, guys.
Whoop whoop. So crazy. It's just gone by so fast. So length is normally measured long ways. Height is normally up and down. It depends on what you're looking at though. Okay. Yes, so number 12, your area will be this length times this height, and your perimeter is all four sides added together.
Yeah.
Colored paper from home, so you guys have more to use.
I can take this home with me, right? Just practice on it. Home.
Say it one more time.
I can take this practice home.
Yeah, absolutely, absolutely. No, take your time with that. You've got all week.
Yeah, awesome.
Alrighty, you guys heading out?
Yes,
I will see you tomorrow.
absolutely. You then.
See ya. I'm excited to see what you've got going with yours, Star. Fairy lights and all of that.
Yeah, I was just playing around with it.
Aw, I love it. I bet that's gonna be really cool.
Okay. Did you, videotape that cube stuff?
Currently videotaping. So if anyone wants to watch a project happen in real time, I'm
Well,
doing it now.
I do, because I didn't know what this, surface and all that was.
Right. It's new
That's
stuff. So there's a
all
little
new.
bit of research that'll go into it. But at any point during this week, if you or anyone else wants to go in depth on any of the topics, we can do that. We can do a whole lesson on it if you want.
Okay, cool.
So no
That was
worries
so
there.
much fun.
Yes,
Okay, well, I'm ahead of the game. I've got
you are.
the one part done.
Mhm.
I'm hoping I did it right, because I'm not taking it apart.
Well, bring it in tomorrow
Okay.
and bring in any other materials that you might want to use for your project. And I'll look at it and see
Okay.
what's missing on it and what's good already on it. And
All right, perfect.
I'm sure it'll be great.
Because I didn't do it like solid like this.
Uh-huh.
I just actually did it like a 3D.
Oh,
Like
with no
this.
faces.
Yeah,
So it's like the
completely
skeleton
open.
of it.
Yeah, it's just the
Oh.
skeleton. Where I
Okay.
did, because I wasn't sure exactly what we had,
Right.
And so I just went and got a small piece of foam, thin foam board,
Yeah.
and I just cut out, little links.
Well,
and-
bring it in because
Okay.
it's possible that could still work. We could just say that some of the faces are imaginary as
Okay.
long as we still include them in our calculations.
Okay.
So bring it in and we can look at it together.
Okay, if nothing else, we could do the faces with, oh gosh, what is that called? It's a thin plastic that you can use for like windows and stuff for instructions.
Oh, I know what you're talking about.
I
Yes.
could cut those out and we could tape
And
it.
I have lots of like plastics that we can use.
Yeah, so
So-
we can put the faces on it.
Yes.
That way it's still there and you can still see the fairy lights through it.
Sounds good.
All right.
Well, I'm excited to see it.
Okay. All right, then I am out because I've got to run by schnooks.
All right, girl. Well, I will see you tomorrow.
You know it. It's gonna be so, I figured you can like hang it up.
Yes, and I'll be able to use them for example projects for next time I
You
teach
keep
this.
it, Yeah.
Yes. All right. Bye, Star.
Bye, sweetie.
Okay. So one face is 2 inches times 2 inches. Hello.
Everyone's out of here.
Yes, everybody's out.
I'm gonna do my final.
All right.
Yeah, I'm gonna do the final. I'm not.
I don't blame you, girl.
Yes,
I know sometimes doing these projects is fun, but if you have a lot of other things, it's very time consuming.
One thing's going, this will never get done. Automatic fail. I'm gonna say this.
No, you'll do great.
sorry.
Oh, you're
Automatic
okay.
failure.
All right, girl.
All right, I'll see you tomorrow. guys.
See ya.
All right, all right, all right.